So before we start talking about tokenization, we're going to create our own little text that we can play around with. So what I did is I simply copied a small portion of a larger article from scientificamerican.com, and you'll see that link on your screen. So what you want to do is you want to take this small portion, copy and paste it into Word, and then save that as a .txt file. You want to start copying from the starting point that says the answer to the question, and the ending point is the answer is unclear. So simply use the find function on your browser, and you should easily be able to find the starting point of this portion that I want you to copy, and also the ending point of where I want you to stop. As I mentioned, save this as a .txt file. And where you want to put this is, remember the lesson about the Jupyter Notebook? I asked you to create a folder. So wherever that folder is, do a search, is where you want to put this .txt file in. So now we're ready to read our file in, and we can do that with the with statement. So we'll type with opening parentheses, double quotation marks, sample underscore text .txt, closing double quotation marks, comma, and then we've got quotation marks around R, and we're saying we want to read this file as opposed to write, for example. Closing parentheses as F colon, and then sample underscore text, that is our content, equals F dot read, opening parentheses and closing parentheses. And then we will type in sample underscore text, and this gives us our output. Now before we start processing this text, we need to convert all the letters to lowercase to standardize this text. To do that, sample underscore text equals sample underscore text dot lower, opening and closing parentheses. So with that out of the way, what is tokenization? And tokenization is simply a process where we split longer strings of text into smaller pieces, and we call these smaller pieces tokens. So for example, when we take a larger chunk of a text, so let's say paragraphs, these can be tokenized into sentences, and sentences can be tokenized into words. So what this does is it turns an unstructured string, so a text document, into more usable data, which can then be further structured and made more suitable for machine learning. So further processing is generally performed after a piece of text has been appropriately tokenized. Now there's a number of ways that we can go about tokenizing, and we're going to go through 3 different ways with you here. We're first going to start by tokenizing our text by using pure Python. And all we're going to do is split the whole text with spaces. And we'll do that by typing in tokens equals, opening square brackets, word for word in sample underscore text dot split, opening parentheses, closing square brackets, and then we'll do print and pass through the argument tokens, and this is what we get. So you see that the whole text has been split by having spaces. We're going to do the same thing now with something called NLTK tokenizer. And we're going to type in tokens equals NLTK dot word underscore tokenize. And then we're going to pass the argument sample underscore text. And then we'll print and pass the argument tokens. Now, we can also tokenize the text with custom regex patterns, which is called regexp tokenizer. So regex is simply short form for regular expressions. Sometimes the short form is regexp, exp. So by using this function, regexp tokenizer, we can apply highly customized and detailed tokenization that can help us extract more information without doing further processing. So let's type from nltk.tokenize import regexp tokenizer. The next line, tokenizer equals regexp tokenizer. Now what we're going to do is pass our pattern as the parameter. We're going to type R apostrophe backspace W plus apostrophe and then closing parentheses. And the reason that we're doing that is we want to separate the sentence into words without punctuation. And we do that by using the regexp tokenizer and passing this particular pattern in as our parameter. And we do this because when you do text analysis, you want to get rid of the punctuation. The R letter as part of the parameter signifies that the upcoming expressions are part of the regex pattern, specifically the expressions that are in between the apostrophes. The backwards space W is used to find word characters, and the plus indicates that we're interested in patterns where there's just one word, one character, like A, but we're also interested when there's more than one character, so when it's AS, for example. So let's finish up the coding part now. So tokens equal tokenizer dot tokenize, and then we'll pass sample underscore text, and the next line we'll just print it, so print, and then we'll pass tokens. Now as you see this output, we don't see any punctuations, and this is because we tokenized by words by using regexp tokenizer. Now let's see the frequencies of each token. This is quite simple and straightforward with NLTK. We'll just type in token underscore FREQ equals NLTK dot FREQ DIST, and then we'll pass tokens as our parameter or argument. And what this does is it returns a dictionary-like key value pair, and in order to find a frequency of a token, we simply use that token as a key within the brackets, just as we do in dictionary types. So token underscore FREQ, and then in those square brackets we're gonna pass Hubble, HUBBLE, with double quotation marks around. And what this shows us is the number of times that the word Hubble is inside of our text, and when we see that output we can see it is 5 times. And we can easily plot this with an embedded plot function. So we'll do %matplotlib inline, and then token underscore frequency dot plot, and then we're going to pass 20 comma cumulative equals false, closing parentheses. And there you see our output. And as you can see from the plot, the words like a, an, the, be, etc. are highly populated in the text, but don't add any extra information in the sentence. So such words often create noise when you're modeling, and such words are known as stop words. So now let's check out the stop words that we have, and we'll use our NLTK package. So we'll type from nltk.corpus import stop words. Next line, stop underscore words equals set, opening parentheses, stop words dot words opening parentheses, apostrophe, English, closing apostrophe, and then 2 closing parentheses, and then next line we'll just print it, print, and then we'll pass the parameter stop underscore words. So after we run that, there you are. There's all of our stop words. So now what we can do is we can filter each sentence by removing the stop words. So I'm going to go ahead and just provide the code that's going to allow you to remove the stop words, as this video has gotten quite long. But if you have any particular questions about this piece of code, you can ask in the Q&A. And I'm also going to copy and paste this part of the code. This is just going to allow us to see our frequencies of the words again. So we want to see a plot of it. And as you can see from that plot, the plot makes more sense because now it's showing us that the text in terms of count of words is mainly talking about universe and Hubble, now that we've taken away those unimportant, annoying stop words. Now what we're going to do is we're going to tokenize this text by sentences. To do that, we're going to type in sense equals NLTK dot sent underscore tokenize, and then we'll pass sample underscore text, and then we're just going to print. So print, and then we'll pass SENTS as our parameter. So now what I'm going to do is I'm going to search for the first row and see what it gives me, and then I'm going to search for the second row and see what it gives me. And as you can see, the sentence tokenization is basically working because it understands that when it sees punctuations such as periods and question marks, it understands that that is one sentence. So when it sees a period or question mark, it knows that that's one sentence, because when we searched for the first row, as we did in this first line of code here, it gave us the first sentence. And when we looked for the second row, it gave us the second sentence. So that's really, really good. But what if we also want to remove the punctuations as well? So we can go about this in a couple of different ways. We can first rather come up with a list of unwanted punctuations or use a ready-to-use list in Python. So we're going to go ahead and do the easier way. And the easier and simpler and faster way is to use the string package. So the first thing that we're going to do is we're going to import string. And string is just a has predefined punctuations that come along with this package. So we'll just import string, and then we'll type in string.punctuation. And these are all the predefined punctuations that it has in this package. And then what we will do is type new underscore text equals, and then 2 apostrophes, dot join, opening parentheses, opening square brackets, I for I in sample underscore text, if I not in string dot punctuation, closing square brackets, closing parentheses, and then we are going to print opening parentheses NLTK dot word underscore tokenize, and then opening parentheses new underscore text, and we have 2 closing parentheses. And what we've done is we've joined all the characters except the punctuations.